Let's take a look at this problem. Okay. Find an expression for f of x and state its domain. F is a function that takes a real number x, so that's f of x equals x, and performs the following three steps in the order given. 1. Make the quantity the denominator of a fraction with numerator 4. So we got 4 as a numerator. We take our previous transformation and put as our denominator. Then step 2, take the square root. So we're going to take the square root of the previous transformation. So we got square root of 4 over x. And then subtract 13. So we got square root of 4 over x and then minus 13. Okay, now this is our function, and I doubt they probably simplify it more than that. You could, but it's a little bit tricky. But let's talk about our domain. First off, I notice I got a fraction here. It's actually a fraction inside of a square root, but it's still a fraction. And we cannot have the denominator equaling 0. So what we do is we set the denominator equal to 0, and then solve it. Well, this is already solved. Now this is the value we cannot have. If I were to put 0 in for the denominator, I have a division by 0. So x cannot equal to 0. Okay, now we'll come back to that. Now we got a radical with an even index. So we're going to set what's underneath the radical, the 4 over x, and we're going to set it greater than or equal to 0. Okay, now to solve this, excuse me, we could multiply both sides by x, and when we did that, we'd get a 4 here, and we would get a 0 over here. So it doesn't go anywhere. So what you might typically think as sound algebraic logic doesn't work. But it's even got a bigger issue than that. Since we don't know what x is, remember if you multiply both sides by a negative number, you'd have to flip your inequality symbol. So there's two big issues with that. Well, this is one where there is a process for finding this, but you probably haven't seen it. It's how to solve a rational inequality. And there's steps for it, but we're just going to think through the problem. First off, we're wanting to know where it's greater than or equal to 0. And this 4 here is positive, so we don't need to worry about that. It's already positive. So really what we're wondering about is when the x is going to be greater than or equal to 0. So we're just focusing on the denominator. Well, this is already solved, so that says that x is going to be greater than or equal to 0. That would be a bracket on the 0, and it's going to positive infinity. But right up here, we said that x cannot equal to 0, so this becomes a beginning parentheses 0, comma, infinity. And this would be our domain. Now, if you had a different problem, where you had a square root of like 5 over x minus 1. And you still have the same issue where you're setting that greater than or equal to 0. And since the 5 is positive, then what we're really concerned with is x minus 1 is greater than or equal to 0, which would give us x is greater than or equal to 1, except for x cannot equal to 1. Because that would cause a 0 in the denominator. So you kind of see the pattern. Now it becomes a little bit trickier if you have a negative on top. If you have negative 2 over x, for example, like this. And the question is still to find the domain. Well, if we set that greater than or equal to 0, that negative messes it up there, but that's okay, because I can move the negative down below like that. So then, since 2 is positive, I can ignore that. I can set the denominator greater than or equal to 0. Now, if I divide both sides by -1 to get the x by itself, we have to flip our inequality symbol, because anytime you divide both sides by a negative, you have to flip your inequality. And then became a less than or equal to, and 0 divided by anything is 0. Except x cannot equal to 0. So this tells us that x has got to be less than 0. And it makes sense when you think about it. If you, for example, put -5 in here, you'd have a negative divided by negative, which is positive. Our big thing is we cannot have a negative inside of a radical with an even index. But anyway, I digress. These two right here are answers.